Hello and welcome. This video might be on a little bit on the longer side. That's because we're reviewing practically everything we did this unit when it comes to solving systems of linear equations. We've graphed, we've substituted, we've eliminated recently, and today we learned about inspection. So let's talk about when it's best to use each one. So graphing is the best method to use when equations are written in slope-intercept form. Go ahead and fill this in. You should know what that looks like. Y equals, that's right, mx plus b. Which variable is my slope? That's right, my m. Which variable is my y-intercept? That's right, my b, right, where the line hits the y-axis. And the slope is a fraction, right, because it tells you what directions you're moving. It's also helpful if the problem provides a coordinate point. Okay, so let's take a look here. Try to your own to label what is the slope. First of all, what does the slope represent? The change in y over the change in x, those directions. And b is the y-intercept. See if you can identify these things before I write it in. Absolutely, my slope is going to be up 3 over 2. What's your y-intercept? -2. What would that look like as a coordinate point? 0, -2, right? That's our point right there, okay? Down to substitution. It's the best method to use when at least one variable is already isolated, right? We did this right before break, or when a variable can be easily isolated. So if I had y equals 3x plus 4, y equals 2x minus 6, right? You know y is equal to y, right? This should be ringing a bell. And what would that look like? 3x plus 4 equals... absolutely 2x minus 6, right? Hopefully it's ringing a bell, right? That's when you can just set y equals y. Sometimes you might have to substitute y for a binomial. Let's say if this y was equal to 6x plus 8. What could you do here? You could substitute this binomial, remember? Substitute this binomial in for y right here. And then you get 2x. See if you can fill this in on your own before I continue. Minus 4 times what binomial? 6x plus 8. Yeah, I know you're like, oh, I remember this. Yeah. Right, substitution here. Or you can do it when a variable's easily isolated. Let's say if I just have x here, right? That way you can isolate x and then you can substitute for x for that binomial. What would you do here to isolate x? Yeah, you would just add 2y on both sides, which would give you x equals positive 2y minus 1. And then you would take this binomial and you would plug it. Yeah, remember that? Yeah. So that's substitution. More recently, though, we've been working with elimination. And elimination is the best method to use when the coefficients are what? Right? When the coefficients are opposites. Or can easily be turned into inverses by multiplying what? What do we usually multiply by to get inverses? -1. Or by the lowest common multiple. And this is what we did yesterday, right? So take a look down here. If I wanted to just easily eliminate, what would I have to put here? What term would I have to put here for easy elimination, right? I would put its opposite, -8x, just like that, right? Now take a look here. We don't have opposites quite yet like we did over here, but what could we do to one of these equations to get opposites? That's right. We could multiply one of the equations by -1, right? Because then what's the point of doing that? Why would I multiply this equation by -1? Because then I'd get -4x, positive 6y equals positive 12. And these here are going to give you opposites to eliminate. Right here, ooh, this one we did on Tuesday, which is not quite ready to have opposites yet. And it's not that I just have to multiply by -1, but I see I might have to use a multiple. So 15 and 5, 15 doesn't go into 5, 9 doesn't go into 7, 7 doesn't go into 9. But -5 goes into 15, right? I have opposite charges here. So what would I multiply this bottom equation by? You already know the vibes. 3. Ask yourself, why would you multiply this whole bottom equation by 3, Mr. Lyons? Because then I get -15x minus 21y equals 3 times 0, 0. That way, I have opposites now. I hope this is ringing a bell, right? We're just putting everything we learned in this unit together, right? Over here, this is what we did yesterday when you don't even have to just multiply one equation. You have to multiply both equations, right? And you use the lowest common multiple. And the easiest way to find that out is just to look at the coefficients and say, well, 7 times 2 is 14. 2 times 3 is 6. So I'm going to eliminate my y's. That's a lower multiple, right? So what do I have to multiply? I want opposites for my y's. What would I have to multiply the top equation by to get 6? By 3. That would give me negative 6y. What would I multiply the bottom equation by to get the opposite of negative 6y, right? We want the opposite of negative 6y. That's right, I'd multiply not by negative 2, not by positive 2, but by negative 2. Why would I multiply this whole bottom equation by negative 2? Because that way, negative times negative would give me positive 6y. I hope this is ringing a bell, right? And today, quite simply, we did inspecting, which is the best method to use when coefficients of the variables are what? We just did this vocabulary, are the same. Or can easily be made the same. You would use inspection to determine whether a system has no solution or infinite solutions. I'm going to just write it out here. I'm not going to use these 2 lines down here. Infinite solutions, right? So take a look at that first example. You want to take a look at if they have the exact same. So that's 6x plus, 2y equals 8. What would I have to write down here to have no solutions? Flip back to the vocabulary page we just did, right? What would I have to write down here if they had no solutions? Keep the same coefficients, but what would have to be about the constant? What would the constant have to be? It can't be 8. Excuse me. It would have to be something like negative 2, or it could even be positive 2, because 6x plus 2y equal to 8, and 6x plus 2y can't be equal to a different constant. That just doesn't make sense, right? We actually did this today. Take a look at example 2. What if we wanted infinite solutions? 2x plus 3y equals 7. If I wanted infinite solutions, what would I have to put down here for my equation? You already know the vibes. The exact same coefficients, the exact same constants, right? Same exact thing. This is no solution because this is impossible. Like this is impossible here, right? And over here, you can easily tell, right? If the coefficients look the same, look at the constants, you can easily tell that that's going to be 0 equals to 0, which gives you, that's a true statement, infinite solutions as well. Okay? Now, that's all we did today. We're just putting everything together that we had learned in this unit so far, because we're going to be moving on to Unit 4 soon. So Unit 3, Systems of Linear Equations, we solve by just graphing them, right? Put them in Desmos. See if they have the same solution, infinite solution, no solution. We can also substitute if our variables are already isolated. We can just substitute right here like this. We did elimination this week, in which you just cancel out opposite terms, right? And today we just did inspection, where you can immediately look and tell if it's no or infinite solutions. Thank you for watching. Thank you for listening, and I'll see you very soon.